All right, today's lesson is over biconditional statements, and this one builds right onto the lesson we did yesterday, or the last class period. So a conditional statement was just an if-then statement. The prefix bi means to, okay? So a biconditional has two conditions to be met. So before we can kind of dive into that, we need to know another vocab word, and that's converse. The converse of a conditional statement basically switches the hypothesis, or that if part of the statement, and the conclusion around. So if you want to see kind of what it does, if hypothesis, then conclusion. A converse takes these two pieces and it just flops them. The if and then stay put, but those two things get flipped around. So let's practice just writing a converse first. Number one, if tomorrow is Saturday, then we do not have school. So we're just going to switch this around and say if we do not have school, then tomorrow is Saturday. Now here's the thing. Sometimes a converse will change the truth value. So if you think about this one, if tomorrow is Saturday, then we do not have school. In our case, this is always true. We have never had school on a Saturday. We probably never will. Hopefully not. So if tomorrow's Saturday, we definitely don't have school. Now, when you write the converse, it kind of changes that sometimes. If we do not have school, then tomorrow is Saturday. That's not necessarily true. It could be Sunday. It could be Christmas. It could be Memorial Day. We don't know, okay? There's lots of reasons we could not have school tomorrow. Number two, if I don't get enough sleep, then I will be tired. Usually that's what happens, yes. So if I switch this around and say, if I am tired, and remember you can change the wording just a little bit to make your sentence make sense. If I am tired, then I didn't get enough sleep. Well, this one is always true. This one might not always be true. It's a completely different sentence. It means different things. Just because I'm tired didn't mean I didn't get enough sleep. I could have got 10 hours of sleep last night, but I just ran a marathon, and that's why I'm tired. I would never run a marathon, but you get the point. So that's a converse. Now let's dig into a biconditional. A biconditional, again, that bi part means two. Biconditional statements are statements that combine a conditional and its converse. So it's like a 2-for-1 statement. These statements are often called if and only if. Squeeze that in there. If and only if statements. A biconditional is only true if it's conditional and its converse are both true. In other words, the statement must be reversible. So if a statement is true and then you flip it and it's still true, it's a true biconditional. So if and only if, it has a symbol, looks like this. It's a statement that's reversible. It works both ways. Okay, so we're going to break this into pieces. First, we're going to look at biconditional statements. Biconditional statements are always in the format of hypothesis, if and only if, ran out of room, conclusion. So you have the hypothesis part, and then it sticks if and only if, and then it has the conclusion. So it's not an if-then form. So here's an example. Number one, two angles are supplementary. If and only if the sum of their measures is 180 degrees. So this is the hypothesis, this is the conclusion. So if I want to put this back into if-then form and write a conditional statement, what I usually do is I just write if, and then I take the first chunk, as long as it makes sense. Sometimes you have to change it a little bit. If two angles are supplementary, then the sum of their measures is 180 degrees. Okay, so let's think, is that true or false? If two angles are supplementary, then the sum of their measures is 180. That's true because that's just the definition of supplementary, okay? Supplementary means they add 180, true. So the converse, we would just take that and flip it. Sometimes you can keep the noun or the subject up at the front. So this whole thing is about two angles, right? So you can kind of keep the if two angles part, and then you can just switch around the supplementary and that adds to 180 part as your conclusion and your hypothesis, okay? So I'm going to leave the if two angles. That way my sentence makes more sense. You always want to keep the subject at the beginning. If two angles, we could either say add to 180 or have a sum of 180 degrees, then they are supplementary. Okay, read that again. If two angles have a sum of 180, then they are supplementary. So if they add to 180 degrees, are they supplementary? Absolutely. So notice this was a reversible statement. It works both ways, okay? So this would be a true biconditional. If the conditional and the converse are both true, then the whole biconditional is true. Number 2, we had one similar to this on the last lesson. An animal flies if and only if it is a bird. So the conditional would be if an animal flies, then it is a bird. And again, you can kind of keep the subject out up front. So we're talking about an animal. You can keep that if an animal is a bird, then it flies. Now ask yourself, is that true both ways all the time? Can you come up with a counterexample? See, if an animal flies, then it's a bird. False. I can come up with a counterexample for that one. Animals that fly that are not a bird. Let's see, an insect. I don't know, a fly. I don't know if that counts as an animal. Should I come up with something else? Maybe a bat. Is a bat a bird? I don't think so. A bat flies, but it's not a bird. The converse, if an animal is a bird, then it flies. Again, that one's false. We came up with one for that yesterday, a penguin. So this is false both ways. That is not a true statement. Either way. Number 3. This is another geometry one. I want you guys to pause and try this one. It uses some vocab words we've talked about. A ray is an angle bisector if and only if the ray divides an angle into two congruent angles. So, if a ray is an angle bisector, then it divides the angle into two congruent angles. I shortened it by using some symbols. That's true, Okay, remember bisect means cut straight through the middle. So if you have an angle bisector, it's going to divide that angle into two equal parts or two congruent parts. And then flipped around, if array, because array is what we're talking about, I'm going to keep it up at the front. If array divides an angle into two congruent angles, then it is an angle bisector. That's also true. So this biconditional is true. Hopefully we got that. Okay, if it's going to divide something into two equal parts, it has to be a bisector. It was bisected. All right, we are going to do one example where we actually do the opposite now. We're going to write the biconditional. We're going to skip number 2 because I think number 2 actually pops up on your assignment. So I want you to get the chance to do that on your own. So it's going to give us the conditional. We're going to write the converse and the biconditional and say true or false. So the conditional is if you are human, then you need food to survive. The converse would be if you need food to survive, then you are human. Okay, now let's write the biconditional. We haven't done one of these yet. Remember, the biconditional is the if and only if statement. So it kind of has if and only if in the middle, and then it has the hypothesis and the conclusion on both sides. I'm going to write that from the original statement, not the converse. So here was the hypothesis. Here was the conclusion. Really all you need to do usually is just stick if and only if in between those two parts. So you are human if and only if you need food to survive. And let's go through and talk true or false. The conditional. If you are human, then you need food to survive. That's true. If you're a human and you don't eat, you'll die. Okay, true. Now the converse, if you need food to survive, then you are human. That's not always true. There are other things that need food to survive that are not human, like a dog. A dog needs food to survive, but it's not human, so that's false. Therefore, think about the biconditional. You are human if and only if you need food to survive. These can be tricky sometimes because this statement right here, it kind of sounds true. We want to say true because it sounds a lot like the conditional. But remember that if and only if implies that this is a reversible statement. But as we just saw, it is not. This statement does not work both ways, so it's a false biconditional. All right, last part of these notes. A good definition should be able to be made into a true biconditional. Write the following statements as a biconditional to determine if it's a good definition. So we're going to say, yes, this is a good definition, or no, it's not. So, a fish is an animal that swims. Here's how I would write this. Whoops. An animal, because that's my subject, is a fish. That's my hypothesis. If and only if it swims. So we're trying to decide if this is a good definition of a fish. If it's a good definition of a fish, this should be a reversible statement. That way we don't get confused on what a fish actually is. So let's try this. Let's go one way. If an animal is a fish, does it swim? Yep. If an animal is a fish, it does swim. So it works that way. But if I were to reverse this, would it still make sense? If an animal swims, then it's a fish? There are lots of things that swim that are not a fish. So this is a very vague definition of a fish. It's not a very good definition. If I just tell somebody, hey, a fish is an animal that swims, and then I see my friend swimming in the lake, I'm going to say, oh, look at that fish. Somebody's going to look at me and be like, that's not a fish, that's a person, you crazy lady. But I'm going to say, well, somebody told me a fish is an animal that swims, so anything that swims is a fish. That's not true, so this is not a good definition. Nope, bad definition. Okay, number 2, a penny is a coin that is worth 1 cent. So, think about your subject. The subject is the coin, so keep the coin out in front. A coin is a penny if and only if it is worth 1 cent. Let's think if this is true one way. And just so you guys know, if we're talking about 1 cent, obviously we're in American currency, we're in US dollars. So you don't have to worry about like currency from other countries. So if a coin is a penny, is it worth 1 cent? I'm going to say yes. If it's a penny, it's always been 1 cent. That's what we know. And then if you have a coin that's worth 1 cent, again, if it's worth 1 cent, that's in American dollars, then it's a penny. That is also true. I would argue that this is a very good definition of a penny. If someone tells me a penny is a coin that is worth 1 cent, I'm not going to go confuse that penny with a nickel like I confused a person with a fish. Okay, so this was pretty reversible. A coin is a penny worth 1 cent, and a coin is worth 1 cent. If it's a penny, yes, pretty good definition. So just remember, biconditionals have to be reversible. And that's all I have for today. I hope you guys have